So yeah, we're going to be a little depleted on our number of people today. So we're actually recording today's lecture. Some people cannot read it. But Johnny's here. Thank you for coming. And I think Daniel perhaps will attend. We'll see. So let's see. Oh, actually, I want to start off by saying that NTU has recently sent out a notice saying that there's a survey that students can fill out now. It's so they do 2 surveys per semester, I guess, one for midterm time and one at the end. It's evaluation and feedback for me. So it should be anonymous, I think, which I think is good for you guys. So basically, this is valuable for me to hear from you. And if you're feeling more comfortable to communicate whatever you want to me anonymously without revealing who you are, then this is a great way to do it. Okay? It can be whatever you want. It can be positive, negative, critical, constructive, whatever you want. Or feedback to the course, things I might be able to adapt in the second half of the course could be possible, or perhaps for next, if I offer the class again in the future. Okay? So yeah, please fill that out. I think it's open from yesterday to the 28th. Yeah. Some people told me in a previous other undergraduate or graduate courses, they said, well, usually I wait until the end, the final exam evaluation. I guess they prefer maybe at the final they give you actual questions or something to rate, rate the content or rate the presenter and all this kind of stuff, right? But the midterm one is free form, so you can write whatever you want. Okay? I think that's great, because you're all writing anyways, right? You're writers. Okay. I'm not just being silly. I'm actually making a request. So please spend just a few minutes and give me your feedback. Helene, I'm not sure you can do it because you're auditing the class. I think you don't have access maybe to the evaluation. But if you have anything to say, you can let me know. Okay? Okay, so where are we progressing today? We're going on to what we call the discussion, but actually we, of course, are mixing our results and our discussion in many of our papers that we've discussed in the class, but also in your own work, you're probably mixing your results and discussion a bit. Nevertheless, as we talked about before, I like to think about the discussion as a pair to the intro. Okay? This is a really good way, if let's say you've outlined your paper, you've maybe written your methodology, in your results you've started to write about the figures in a very scientific, technical way, right? Presenting the information. So let's say you've made that progress for the outline and started to lay out your results and write a few sentences about them. And hopefully you've written your research questions as well. Perhaps you've even started to talk about, lay out your introduction, right? So you have a framework that you're working with, okay? And now you need to think about how to discuss these figures in more detail, rather than just saying figure 1 shows, figure 2 presents this, okay, in a very simplified format, right? So what I like, a good way to start with this is to actually use what you've kind of outlined in your introduction, right? So in your intro, you will have several references to other works. Yeah, and those are kind of leading your story. Okay, you're comparing to other works, what has been done before, and that's motivating your own work. So by the time you get to your own discussion about your results, again, you should be reflecting back on the storylines from your introduction. Okay. On the other hand, perhaps you haven't written your introduction, and you need to write your discussion first. That's also fine. So you can think about it in the same way, right? Whatever primary sources other works that you're going to be citing about your discussion, you can then bring them back to the intro when you're eventually writing that. You'll probably go back and forth. You want the story to be pretty consistent, but of course the discussion allows you kind of a longer tail to interpret your data. Yeah, if you have a lot of data in particular, you might find many dimensions with which to discuss it. Okay? And whereas the intro is sometimes limited, like we said, to maybe less than 1,000 words. Okay, so if you're struggling about what to discuss, but you've already outlined your intro, the easiest way is just to say, okay, I'm going to take that same outline and try to apply it to my discussion and see what I can build on. Okay, and now I have my own results. All right, so you've seen this slide before, just emphasizing that point again. Nevertheless, something that we might find ourselves in, sort of an issue, is we don't have a real focus, and we're not so focused on the points of our discussion. Maybe we don't have the intro as a reference, and we're wondering what to write. We just start kind of writing whatever about the figures, okay, going off too much detail. And this quote from the Gaston Day book was, I think, funny, okay, where they're talking about some discussion sections seem like a long-winded politician whose speech leads to nowhere, answers which go winding and winding off through the interstices of the English language. So it's like people that just like to hear themselves talk. Maybe that's how you think about me, I don't know. But I sit up here and jibber jabber to you guys on and on. And so hopefully we don't get ourselves caught in this situation, right? We want to have a focused narrative, something that we've outlined in our intro, we can refer back to in our discussion, and keep it a tight narrative. Okay? On the other hand, we might not just lose track of our story because we don't have a focus. Okay? We might also lose track of our story because we have a poor experimental design. Okay? This is a story also from the Gaston Day book. It's about a spider. Okay? How do you guys feel about spiders? Okay? Not a fan. Actually, I have a friendly spider in my office, at least one. He walks around the walls, desks, and everything. And most of you have not visited, a few of you have visited me. So if you're afraid of spiders, I'm sorry, you have to deal with it. I won't reveal it next time you're there, don't worry. Johnny, you look a little worried. You were in my office twice. He's small, don't worry, he's small. And actually, this story is about a jumping spider. Okay, spiders we often think of scurrying, running away in different directions, spinning the web, this kind of thing. But actually, some of them can jump. You know, actually, when I was a kid, in the U.S., typically you're interacting a little more with nature than you are in Taiwan if you live in a big city here in Taiwan. So I grew up in a smaller town, big yard, a lot of nature surrounding us. And me and my brother found a spider one time, in our basement, pretty big one, okay, yay big, okay. Whereas the one in my office is only like this big, okay. Everybody's shaking their head. Anyway, big one. And so we were young boys, and so we trapped it, put something on top of it, Oh, okay, we're gonna let it suffocate, or it cannot survive. We leave it like that. We left it there for more than a day. Like we're thinking to ourselves, if someone trapped us, there's no way we could survive. And then a day later, or maybe a day and a half later, we took it off. We're looking at it, not moving. Must be dead. A little closer.
Oh no! Oh no!
And the thing is big and black and a little hairy, And the thing just jump. And of course, my brother and I were dumb young boys, like almost run into each other, like wow. And wow, so that's a jumping spider, I suppose. But actually, many of these spiders, they have the ability. Sorry, just a tangential story. I'm sure you can find big spiders in Nantou, the more countrified places here, right? Anybody seen? The biggest ones that are easiest to find are in the forest, actually. Whenever I go hiking, you can always see these big spiders. They have very pointy legs, and I don't know what they're called.
Colorful body.
What's that?
Colorful body.
Yeah, usually it's some yellow,
Yellow,
and
red, black.
I don't know what they are. I doubt they're poisonous, but they're usually, I don't know what you call them. But yeah, you can almost always find them. So, but I bet they're not poisonous. Nothing to worry. Just kind of, you pass by.
But they are not hairy.
Yeah,
They're-
exactly.
Right. True, they're not hairy. They look very.
They look like general spiders.
Yeah. So, other than that, I haven't seen too many big spiders. Anyways, this story is about a jumping spider, but it's not really about a jumping spider. It's about a poor experimental design, which then affects our ability to make a discussion. Okay, and we're really focused on how to turn our results into an appropriate discussion. So this is just a silly little story, and it's about a scientist who's trying to train a spider, okay, just like you train a dog, right? Train a dog to sit and shake hands and all this kind of stuff. Training a spider to jump. Yeah. And they thought this would be a fruitful activity. They must really be hurting for science. Can you imagine writing this to your scientific granting agency? Hi. And in order to do so, the scientists wanted to identify how the spider receives the information. You know, you're training the spider, and it doesn't have ears like a dog, right? Maybe this scientist really didn't know anything about entomology. And so they wanted to determine the location of the sensor organ to receive information. So they decided to, they thought that the sensor organ might be in the legs, 8 legs. They thought, oh, this probably, all these legs are receiving this information, you know, all these hairs on the legs. So they cut off the legs one by one. And each time they cut off the leg, the spider, the jumping spider, was able to jump less, right? So it used to be able to jump high, jump a little bit less, cut off more legs. Jumping ability is reducing. And so they realized that after they cut off all the legs, the spider is actually not responding to the jumping command. So therefore, surely he has removed all of the sensory organs, right? So the conclusion from this experiment by this confused scientist was that when you remove all the legs of the spider, you can no longer, quote unquote, hear. Yeah, we removed all of this. So obviously we know that this is an erroneous conclusion. Okay? It's just a fun story that that can send our discussion into the wrong direction. Okay? Again, you have a focused story from the beginning. You have a proper experimental design. It should make your discussion of the data more straightforward for you. Something you can really grab onto. Okay? Just a little example. Okay, so what are really the points of the discussion that we can share? Yeah. Again, you can use the reference of the introduction, but perhaps you need to also outline the discussion by itself if you haven't written the intro. So what are some points you can focus on in this case? I really like this slide. In the points that I'm outlining here for you. I've taken this from the Gaston Day book, but I've adapted it. They provided a few other examples that I didn't find as helpful, and then I added some examples. Okay, so it's not their complete list. But I really think these are a good way to focus your discussion. Okay? Now, there's 7 examples here. You don't have to include all 7 by any means. Okay, and so actually what we'll talk about is that the first 2 are very common. Okay. The last 4, in particular 4, 5, and 6, are really helpful and really make a nice, thoughtful discussion, but are often either avoided or minimized in the paper. Okay. We'll go through some examples where we can see people really emphasize these to enhance the discussion. Okay. So the first one the first one is really presenting and discussing the relationships in your data. So this overlaps a little bit with our results section, right? As we'll see, a lot of papers will combine the results and discussion. Some papers will call it the results, but they'll still be discussing their data. Okay? So when we present our results, we often start off and say, Figure 1 shows our NO2 data, for the city of Taipei, blah, blah, blah. Okay? But then in the next breath, if you're starting to analyze this and you're starting to say, we know that NO2 is correlated with the wind direction, right? So we know it's has a higher correlation when the wind's coming from the north versus the south, all this kind of stuff. This is really more of a discussion of the data, right? And so this is the first part, and that's fine. You mix all of this together. Okay, so this is the first idea where we present principles, relationships, generalization of the results, and it overlaps. Furthermore, we often follow it up with some comparison of other works, right? After you present your data, you talk about the relationships in the data, then you say this is consistent with these works, also done in Taipei or done in Southeast Asia or something like this, right? We'll use comparisons. And these first two are very obvious ways to design our introduction, our discussion, right? And so really, if you're at a lack for anything to write, at least you should be including these first two. Okay, this will give you, if you have, let's say, 3 figures that you've settled on, this just discussing in this manner will give you at least 3 extra paragraphs, right? 1 for each figure. The third one is pointing out exceptions. So you've presented the relationship in your data, whatever it may be. Could be more theoretical, could be modeling, could be statistically based, whatever. But still, some of the data doesn't quite fit. So that's an exception to the data. As scientists, we still present everything, right? Maybe we've taken, we're comparing 50 observation points to our modeling results. And 42 of them are in good agreement with the model, between the model measured values, but 8 of them are not really, we can't explain. But we still present them. We don't want to hide them, right? Does it make sense? Furthermore, one reason we wouldn't want to hide them is that perhaps there is an explanation, but our science is not able to explain it yet. And that's the great thing about science. In 10 years, as we enhance our methodologies, improve our number of samples, we can maybe look back on that paper and those 8 points and realize, oh, this is what was going on. Okay? So presenting that information should still be done, and we always do, I think. We don't try to hide it. You're not really highlighting those exceptions, obviously, if you cannot explain them, but they're still there. Okay? And this is still part of the discussion, right? You're noting, you're often indicating to the readers that these points exist. Okay? And actually, that leads into, perhaps I should have swapped 4 and 5. When you have exceptions, one of the other discussion points is speculating, right? So a common way, time to introduce speculation is when you have these exceptions. We can't explain them, they're exceptions, of course, but you can put out some ideas for why they exist, why there's disagreement between model and measured values. Perhaps it's something you cannot prove, and therefore it is speculation, right? You're saying, well, it's possible that some unmeasured value that we weren't able to collect, would be able to explain this NO2 value, right? Maybe there's some chemistry that's going on, some source of NO2 that we don't know, and that's why our model is not able to match our measured value. Okay. But in this study, we were not able to characterize that emission. Okay? Yeah. So that's speculation, and then of course that is also kind of connected to limitations, right? So you've speculated on the reason, and perhaps you've also followed up and said, well, if it is due to an emission, it's something that this study didn't cover, and therefore, it's a limitation, right? So all these all these aspects really go together, can go together, they don't have to. Okay, and then, so we have speculative material, or just speculation. And just really, it's really an informal discussion of your results, right? You're kind of talking about these relationships in ways that go beyond your study, but open up the doors to other explanations. And this is usually very fruitful, okay, and very instructive for other readers as well. When people are reading your paper and they're looking for ideas, for work, for sort of questions that haven't been answered, okay, something they want to investigate. When they find good speculative material, this is motivational, a motivational aspect of your work, right? And then just to emphasize on limitations themselves, this is often a very key point, especially from a peer review aspect, right? They want, a reviewer wants to know, or an editor wants to know, wants it to be clear the limitations of your study, right? They want it to be clear in the context of other works before you. So you have to put this frame of your limitations in there so that people can know what you did, what you were limited by, how you overcame some disadvantage from a previous paper, but what is still limiting you for future progress, right? It's okay to be open about that. You should be open about your limitation, so you can actually use it in a future work, right? You could say, well, in that previous work, we were limited by such and such, but now we're going to overcome it. Okay? Limitations, speculation. Similar aspect is unanswered questions. Okay? Oftentimes these are posed directly as a question. When there's a discussion about your results and your interpretations, and you may end on saying, this leaves still the question of how important this emission source is to the NO2 concentration we're studying. Okay? So that's not speculation, right? You've already speculated on possible reasons, but actually detailing unanswered questions for the field. Again, a good discussion point here. Okay? And finally, perhaps a more obvious point than some of these others are the implications. Right? This is where we talk about the novelty of our work. Sometimes these are included in the conclusions. We don't detail them in the discussion maybe. Some people like to leave it to a separate section to make it easier to find. Still, you can hint at them. Yeah, you can hint at your implications. Because oftentimes it's a good way to sort of tie a bow on the discussion section. And then in the conclusions, that's where you're putting it all together. You kind of reiterate, you're summarizing your findings in a very concise manner, and you're really putting emphasis on the implications of this as a result. Okay? So I really hope that you can take a look at these for your own work. If you've already written your discussion, I really encourage you to go and look at this list and try to identify in your own writing where you've included these aspects. Okay? I'm positive you can find some of them. You don't have to include all of these aspects, but in most cases, this will give you more discussion material and helpful discussion material. Something that will assist the reader and the editors, peer reviewers, to understand the story of your paper, understand the narrative, follow along, right? Okay, so yeah, hope that you can understand these. Any questions about these points? Okay. So as I mentioned, the limitations can really be an advantage, right? We discussed in previous lectures and discussion times about how to characterize future work. And oftentimes we'll get to our conclusions, perhaps even in our discussion, and we'll start to discuss future work. And this is where the presentation of our limitations can be useful, right? You say, this study was limited by this, did not cover this. However, in future work, our group, or you can specify your group, or you can say it's imperative that this field eventually overcomes this limitation and solves this question, right? So you can actually use this to your advantage. And then when you make this clear, you know, it's easier for the reviewers and the editor and your readers to be able to place your paper in the scheme of things, okay, in the scheme of the overall scientific field, to understand how important it is, what kind of message it delivers, and how it can be used as a building block for future research. That's helpful, okay? And at the same time, if you feel like you're putting yourself at a disadvantage because you're emphasizing the limitations, at the same time you can pair it with re-emphasizing the strengths of your paper, right? You're re-emphasizing the advantages that your study brought, highlighting the fact that you still have some limitations, but overall, this paper is delivering important content to the field. Okay? As an example of a peer review process that I went through recently at NCU when I was there in Zhongli, this is a paper I was the corresponding author on with a PhD student there. And so this is work based on CMAX simulations. So this is a air quality modeling system. Okay, so we basically are often trying to model PM2.5 or ozone, some pollutant, and compare it to observed values. And we focused on Taiwan. This one in particular was focused on long-range transport from China. And so what we were doing was we were using satellite-based pollutant values. So we have satellites that can measure pollutants through a column, okay? And we use those measurements to try to fix our emission inventories. So in China, for instance, we know roughly in Beijing how much NOx is emitted, right? But if we use a satellite measurement, we can actually adjust the emissions in a city like that, which then eventually can deliver pollution all the way down to Taiwan, right? So, this was the study. We went through the peer review process in a journal called Aerosol Air Quality Research, and the reviewers were positive, but they had some requests. They wanted some discussion about the uncertainties. We had included a little bit, but we didn't separate it into a different subsection. So we made the decision collectively in our co-authors and said, okay, let's really include a more complete discussion about the uncertainties and limitations. And so we actually added a huge section just for this. And in the end, it's quite helpful. I think it's good not only for the student, okay, and our co-authors, but also other readers. I think they will find this to be instructive for them, right? As they're reading our work, they can understand more completely about the uncertainties of the work in a separate subsection. So this really emphasized on the limitations. Perhaps we could have already included that more than we did, but it was the peer review that stepped in and said, it needs to be more accessible, okay? So, just an example of some situation you may find yourselves in as well. It's fine. Some other examples here. This one is from a journal that we've mentioned before, Environmental Science and Technology. This is a drone system, okay? They're trying to measure aerosols over the ocean. So I don't know if you know, but as the waves break over the ocean, it actually generates some particulate matter in the air. So they're using, in this case, unmanned aerial vehicles or drones to do this sampling. So the way they had broken up the results in discussion, I characterized their subsections as this. Basically, they had one result and then a discussion, and then one result and then a discussion. Some of these are mixed a little bit. presenting some data and discussing it. But generally, this is how they constructed this section. Okay. So the first one, they're really discussing they're presenting the performance of their drone or their UAV, and then they're characterizing some of the theory, how the theory relates to their measurements here in the discussion part, and then they're presenting data in a vertical direction as well, and then again doing some calculations and interpreting their data. Okay? So this is how that study was constructed, and I wanted to highlight some of the additions they put in their discussion section. So they say here, although this initial sensor package was relatively light, future work will look to decrease the weight of the package to increase the total flight time, ensure longer sampling duration per sample flight. So this is clearly some limitations that they're pointing out, right? And this is still in their discussion section, and that leads directly into the next paragraph about future application. So what I just mentioned is that we can use this to motivate our future works. In this case, this group most likely had already done the future application research, or at least some part of it. Right? So a lot of these groups, they will try to time it. Okay, they'll do one research experiment, and then they already have designed the next one, but perhaps they haven't fully completed it. But the first paper, at least they could mention the next one, so that when they submit it like 2 months later, it'll be a very nice fit, right? Say, okay, this one mentioned our future applications, and now we're going to submit this. This is our future application. We'll reference that first paper. It will tie together nicely. Still, even if they're not doing it, it's easier for the other groups to find that are trying to build on their work, right? Okay, next one. Later on in their discussion, they said, although a more quantitative assessment of this turnover and the particle concentration is outside of this work, it provides an interesting science question that future flights and studies may be capable of addressing. Okay, so again, they could be setting up their own work. They could be motivating other groups' works as well. They know probably dozens of other groups are trying similar things, and they pose it as an unanswered question, right? When you pose it like this, and you indicate that there's really a question remaining in the field, this is it often is related quite well to the reader. When they read this, they're thinking, oh, it's like reading a story. They say, oh, there's still a question here. Okay, so when you're reading a book and you're getting towards the end of the chapter, and there's a bit of a cliffhanger, what's going to happen next? Yeah. So this is a nice way to find information that should be resolved, but wasn't able to be answered in this study. Okay. Here's another one. This is one that I referenced a lot in my PhD. So this is more chemistry based. Again, the way they design their results in discussion, they mix them together in the title of the section. And then basically, I would say there's 2 results sections where they're focused on some measured values of gas phase compounds, and then there's some modeling presentation as well. And the rest, really 2/3 of it, is a discussion. Okay? And they really do extensive discussion of their data results. Extensive. You can read all these subsections, perhaps understand them or not. I also like some of the language here in what I call the research statement. They say, so this is about measurements they did in Mexico City of pollution. Mexico City is a very highly polluted urban area in the world, and great for atmospheric chemistry. So it says, as a result, Mexico City experiences high pollution levels. This study was an opportunity to develop a better understanding of the high pollution levels of ozone and particulate matter. It also stretches the envelope of polluted environments that have been studied with the measurement suite that includes OH and HO2. So I really like this language in terms of highlighting the novelty of your work, right? If you really think that this is a good fit for your own study, in terms of the novelty, the impacts, it stretches the envelope. It pushes the boundaries, right? You're really using more colorful language. And so I'm doing some color coding here to emphasize how detailed their discussion points are here. So this example actually is utilizing some of the discussion points that we've been talking about. Okay? So the first part here, this is just a small component of the discussion actually. As I said, there's 4 subsections of discussion material, and these are just 2 short examples, but they're packed full of information. Okay? So first they say that they present some of the relationships and emphasize the significance of their data. Okay? They say that these 2 values are in balance to within the combined 2 sigma uncertainties. Okay, this is a presentation of the relationships. And then they go on to say the difference should be 0 for the entire day, but it's actually slightly negative during the morning rush hour, implying greater than expected production. So this is an exception, right? They're pointing out an exception here in their data. It's very clear. And then they use a comparison and they say smaller differences at morning rush hour were observed in Nashville and New York City. Okay? So already within the first short paragraph that I show here, they very clearly do some presentation, some exceptions, and some comparison to other works. So they can tie into these points very easily. So in your own case, you can think about it the same way. And they go on to say that these differences at morning rush hour are not beyond measurement uncertainties, yet they are persistent from study to study. So they're pointing out that although the uncertainties on the data is kind of huge, okay, huge, and they're not able to really, they're not able to say that it's truly an exception, okay, at that point, but it's still persistent. They consistently see some misprediction here. Okay, and then the last 3 points are about unresolved questions, speculation, and limitations. So again, these kinds of 3 aspects can fit together really well. So they say, if the measurements are correct, the imbalance in the production and loss indicates problems with known photochemistry. Okay? Problems. So they're really indicating some unanswered questions, right? Indicates problems. Some aspect may need re-examination. That's in the yellow part there, right? So they're really highlighting a problem or an unanswered question, and then they speculate in green about how that could be. Okay, you could read through that yourself. And then in purple, they say the uncertainty in the Mexico City measurements does not allow us to distinguish between removal or rapid cycling. So they're highlighting the fact that they are limited in this aspect, right? So they're putting the problem out there, they're speculating about the reason, and then they're finally concluding that there's still a limitation in their own work that doesn't allow them to answer this question. So it's fine. You put this information out there, even though you're not able to resolve it, it's still a discussion piece, right? It's there for the scientific community to see. It's constructive, it's thoughtful. You know, they go through some of the theory here about how this could be, and it gets our problem-solving ideas flowing, right? Okay, so just as an example there from 2 studies. Okay, maybe we take a short break we take a short break and we come back and we take a look at some more examples. Anybody has, help me, Samuel? You guys have written, put words on the paper?
Yes.
So how many figures have you written about?
Maybe 5 figures.
5 figures, oh, okay, that's quite a lot. So have you started to discuss them in detail, or you are still just presenting the basic facts?
I have outlined some resource and discussion points I want to mention in the words, but I try to organize them into clear storyline.
Okay.
So it's taking some time to organize them.
Mm.
And I have to define which points I have to use and which is not, or is unnecessary.
Yeah, I got it. So, okay, so yeah, I think you'll, at some point soon, you'll probably be faced with, you know, what points to make about these figures. Okay, so maybe you can look at that, that slide to kind of reflect upon. As I said, you don't have to include all those types of points, but if you are wondering about some of the language to use and how to present the information, you can utilize some of the examples that we have in class in addition to that slide. Okay? Just it's a little bit, obviously it's a little bit more difficult to write about than just presenting a figure, because some of the language may not be as clear to you. But I think after we go through some examples and of course, as you read other papers, you can now look for those, how people write about limitations, how they write about speculation, okay, and so on and so on. So you can use those for your reference. How about you, Hubing?
I only need discussion part.
The discussion.
I only need the discussion part. I finish the result and the discussion.
Oh, so you're working on the discussion now?
Yeah.
Oh, okay. So do you find it difficult to make progress on the discussion?
Yeah, because yeah, it's difficult.
Huh?
It's difficult to learn discussion.
Difficult, right? Okay. So yeah, again, it's the same for Samuel. Use that slide if it as instruction, you know, as a motivation, reference, whatever, and some of the examples that we've gone through already and that we go through now, I think can be helpful to you. Okay? Get you really thinking about the ways to present that information if it's not coming to you easily. Okay. So this study, this is one that I've presented in the past. This one is, again, it's focused on pollution, so maybe not quite in your wheelhouse for everybody, but basically they use a satellite instrument. I mentioned earlier, measuring pollution through a column. Yeah, you've got a satellite above looking at the surface, and it's through the column estimating how much NO2 or carbon monoxide, CO, are in that column. And we can actually use those pollutants as a ratio, in a ratio form, to tell us about emissions on the ground. This is what the study does. So they compare the satellite-derived ratio of these pollutants to the emission inventories. Okay, so I mentioned emission inventories earlier. For Taipei, we know roughly how much NO2 is emitted from transportation, from industry, and so on and so on. But those are not; those are just sort of book values, right? Something that we update every maybe 1 or 2 years, every 3 years, about the emissions in an urban area. So by having measurements, now we can actually have additional supporting material. Okay? So this, as they say here, this study investigates NO2 and CO retrievals from the Tropomi satellite to improve the quantification of burning efficiency and emission factors. This is from their abstract. And actually, Tropomi is not the satellite, so it's a little bit of mistyped. It's actually the instrument. The satellite is like Sentinel-5, something like that. Has anybody heard of this satellite? You guys, atmospheric science people? You guys use satellite data, right, sometimes? But not this one? Never mind. Okay. All right. So how do they construct their discussion? Okay. So I've highlighted, tried to highlight some of their key points here in their results and discussion. Take note that that again they've mixed the results and discussion in a very conventional format, and so it kind of allows them a lot of flexibility to present this information. So first, they're really just talking about the detection of these pollutants over each city. They focused on maybe like half a dozen cities throughout the globe. Okay, and so the first example here, they're discussing some of the relationships in the data, and they use the language of this demonstrates a relatively short data averaging period. Yeah, is sufficient to detect hotspots of CO pollution, such and such. Oh, so before they say this demonstrates, of course, they're already presenting the results. They're talking about a figure, okay, and then now to kind of making a conclusion about their finding of that figure, right? This demonstrates that a relatively short data average. Okay, this is a good way to transition into more of a discussion-based material. Okay, it's not just a straight presentation of the figure anymore. Now you're kind of going on to further talking about it. Okay, presenting, and again by the end of the paragraph, it's the same idea. It demonstrates variations in the enhancement ratio can already be seen by eye. Okay, so this is actually getting into a little bit of implications too, right? They're making a kind of a big statement about this whole paragraph. And actually this is 3.1, I think, in its entirety. Okay, so this is a fairly short little section just to get the study off the ground. And then they go on to start to compare, as I mentioned, using the satellite data versus the emission inventory, sort of the ground data that we feed into a model. And so they're comparing the emission inventories to the satellite data, and they do a lot of discussion here. Okay, so this is really a comparison between two types of data sets, and they're talking about these data sets have similar patterns. They give Pearson correlation coefficients, and then they talk about exceptions, however, are clearly 60 to 85% larger than the satellite values, okay, and so on and so on. So they're noting some exceptions between these comparisons. And then they go on to say, however, it is complicated to identify the main factors explaining these differences. And so this could kind of be characterized as an unanswered question, or just stating a limitation. And then they go on to say as well, we also acknowledge that our treatment of the photochemical removal of NO2 is simplified. This is a really nice and common way that we present a limitation, right? Especially if you're making assumptions about a model, okay, and you have to simplify. An assumption is essentially a simplification, right, of your theory or your methodology. So really presenting this limitation as something that has been simplified. And this is a good way to start off that kind of discussion. Okay? And then at the end of that paragraph they conclude, again, provide a concluding sentence that says, hence, to further improve this accuracy, a more sophisticated treatment is required. Okay? So they're setting up future motivations for studies to resolve this limitation, right? More sophisticated treatment is required. They're being very honest. Okay? They go on and try to validate the ground-based, try to validate the satellites using ground-based measurements. So this is not using the emission inventories, which are just a book value based on various things. And so they're now comparing to some surface values. And again, this requires discussion of data compared between two kinds of data sets. And they leave the implications primarily to the conclusion section. Okay? And the one thing, this study is pretty cool. I recommend you take a look if you're interested. But the one thing you'll find is missing is the comparison with other studies. And this is actually actually pretty rare that we leave that out. This is, comparison with other studies is so obvious, right? It's such a, if you don't have anything else to write, you at least are going to compare to the other studies that you mentioned in the intro, right? You're at a loss for words, where to go. You say, okay, I'm gonna, just to get something done, talk about this other study, how my results compare. Actually, they barely do any of that in this discussion. So that's one missing component. Otherwise, it's pretty well laid out. It's thoughtful. It's constructive. Everything. Okay. So I believe you will not make that same mistake. I believe that you will be very quick to compare to other studies because that's such a it's a low-hanging fruit. Easy to take care of. This is another one. This one is about the Brewer-Dobson circulation. Does anybody know what this is? Atmospheric science people? So it's different than the MJO. Last time we talked about the Mann-Julian oscillation. This has something to do with circulations that start in the tropics, affect the upper troposphere, lower stratosphere, so very high, 15 kilometers in there or so, and then they impact outside of the tropics and circulate down into above, even north of Taiwan area. And in doing so, they're looking at the impact from El Nino, which you hopefully know, impact from El Nino on this circulation, but really, they don't mention it in the title, but really they're interested in ozone because part of our ozone in the stratosphere, in the troposphere, comes from the stratosphere. It's really high concentration in the stratosphere, and there's some intrusion that happens that penetrates into the troposphere. Okay. So they're looking at how this circulation impacts these intrusions a little bit, and how El Nino itself is impacting that circulation. Also a pretty cool paper. Sorry, both of these papers are from atmospheric chemistry and physics that are on ACD. Okay. So this is how they've constructed the results and discussion. You can see that this is similar to the Albright et al. Paper. Remember that paper, the first one we discussed? They didn't have any section called results. They had, each of their sections had a specific title about what they were doing. So this has the same format, essentially. They wanted to tell you specifically what they're getting at least in the section 3 and 4. And so they've kind of mixed results and discussion in one, and the second one they mixed discussion and implications. Okay. So again, in this first plot here, they're comparing ozone anomalies between modeled and measured values, and on the bottom is one of the El Nino INSO indices. Okay, so they're again trying to look at these trends together. And so they're presenting these findings here, trying to compare these, and they say generally a consistent picture of interannual variability emerges between the observations and model simulations. Okay, that's a nice sentence. It's a nice way to discuss this comparison. So talking about consistency, similarity, they're talking about these relationships that we discussed as point number 1. Right? And then at the end they do some speculation. They say the factor of 2 difference between the measured and model value is likely due to the lack of ozone chemistry in the boundary condition. Okay? So again, a typical language for speculation is you may say is likely to, could be due to, right? So you're indicating something that's not sure. Okay? You're speculating. It's clear you're speculating. You're saying something is likely due to. That means you actually don't have the quantitative or even the qualitative data to prove it, to support it, but you're going to bring it up as a discussion point, right? So that's why we call it speculation. And that's fine. It's good. It shows that you're being thoughtful, actually. It shows that you recognize that this could be an answer to that question, and you should be thinking about it, even if you can't confirm it. Okay. This is another presentation of similar data showing these ozone anomalies, but on a temporal basis. So this is the INSO index again, and so you can, if you know anything about INSO, you'll know that certain years are very strong El Niños, and they're showing some of the, no, this is latitude, not altitude. They're showing some of the ozone anomalies according to the El Niño events. So again, they get into some speculation here, where they say simulation. Let's see, southern is smoother than that in this model simulations driven by the reanalysis data, likely due to its too strong tropical upwelling. Okay? So again, they're speculating. They're basing this speculation on some other studies, right? So based on some other studies that have shown certain relationships, they're suggesting that this is likely what's going on. We would also call it speculation. They do a lot of comparison to other studies, unlike the last paper we discussed. They finish off this subsection by looking at the vertical distribution finally versus latitude. And so they're showing really the boundary here in the dashed line between the lower stratosphere and the upper troposphere, right? So this is not surface here at this value here. This is more showing the boundary between the two spheres, and they're comparing the different model values in the measurement. Okay. So presenting this, getting into speculation more again. Thus, tropical upper tropospheric ozone mixing ratios may be enhanced not only because of increased convective transport, but also increased fire emissions. Okay, likely to, maybe due to, okay, all these very familiar constructions. Limitations, where they're stating that this chemical relationship between these two pollutants is missing, which might explain the discrepancies. Okay. It's kind of a limitation, kind of a speculation. Okay? And then in the fourth part, the next subsection, they go beyond this connection, okay, between the ozone anomalies and the circulations and El Nino, and they start to look at the structure of the circulation specifically. So they use things like transit time of an air parcel, they use age of an air parcel, various metrics to look at the circulation. Okay? So I won't go through all these examples, but just to know that when you look at these, I think you'll find a lot of the same, similar language. In particular, this paper does a lot of speculation. Yeah, they use a lot of what we would call maybe uncertain language. You know, they use likely to, maybe, due to, could be. This one is there could be an ambiguous relation. Okay? You can find these throughout the paper, and I think you'll find that this enhances the discussion. Okay? As I said earlier, it shows that they're being thoughtful about all the possible reasons about what's going on. Okay? Okay. Yeah, I'm going to go through all these, but just I like to provide these as examples for you as a reference material. Okay? Something that you can refer to when you're writing your own discussion section and wondering how to present the information, which language to use. Okay? So I encourage you to take a look. So let's go to the last part. So that, as I mentioned, in the what they call the discussion is really more of a implication section. So this is where they're tying together some of the discussion points with the implications of the work. And in this last paragraph in particular, they go through a lot of these points pretty nicely. They started off by comparing to other studies, talking about what future predictions from climate models are indicating, right? So this is a good motivational point to start off the final implications of the work. And then they provide an unanswered question that says it's crucial to understand that such future changes induced by a shift in INSO. Maybe I mislabeled this here. They're indicating, yeah, some possible avenue of investigation, right, that people can pursue. So it's a little bit of an unanswered question. And then they actually use the word speculate, okay? It's very clear that they're speculating here. And this is the end of the paper. So, of course, they're not going to confirm any other of the results by this point. And they say, despite the uncertainty, we speculate that the projected change in El Nino occurrence frequency will cause structural changes similar to da-da-da-da, right? So make it very clear about possible things going on and the implications for that speculation. So they really tie together all these points. This final paragraph I find to be very helpful and well constructed in making some of their important points all together. Okay? By the time they get to the implications at the very end, they say, in a future climate characterized by a shift of the basic state towards more El Nino conditions, negative ozone anomalies will strengthen, enhancing stratosphere to troposphere ozone mass flux. Okay? So I told you that really the overall focus is about this movement of ozone from the stratosphere, where it's, you know, sort of good ozone, down to the troposphere, where it's a pollutant, and they're trying to understand, you know, the overall impacts from El Nino on the circulations which drive this ozone movement. Okay, so they're tying this all together with this implication, which I think is done really nicely. So I like this final paragraph as a good example for us. Okay, so hopefully it's fairly clear, these discussion points that we're trying to focus on. There of course could be more. When you read other papers, or perhaps when you write your own, you may find that there are discussion points that are instructive that we haven't mentioned. So if you feel like there are some, or you have a question about some, please ask. Does anyone would like to mention a discussion, a type of discussion point that we didn't discuss? So I gave 7 points to focus on, but don't be limited by that. If you feel like, oh, I found a nice way to discuss my data, okay? And but it'd be great if you could share that actually. Okay? Now, for the Thursday discussion, do you have a question?
No, sorry.
For the Thursday discussion this week, what I would like to do is read through, for each person to go through part of the results of discussion in one of the previous papers. Okay, so this Albright et al., Maina, Yang, or Zheng et al. We've done 4. And in one of those, if you could go through and find 2 examples of discussion points that we presented. Okay? So ideally they'll be distinct. So if one is stating limitations, another one could be speculation, okay? Or one could be comparisons and relationships, and another one could be noting exceptions. So find 2 examples in one paper, and if you could send me the info, maybe send me a slide, and I'll just, you can present it if you want, but I'll probably just use it and present it together on Thursday. Okay, so, but I don't want to duplicate the information too much, so maybe we'll do some, people will raise their hand about which one they want. Who wants to present part of, or who wants to provide part of Albright et al.? Who wants to do Maina et al.? Okay, one for Maina. 2, maybe 2 per paper is okay, but no more. Okay, Maina et al. For this one, for Minghan. Yang et al. Okay, 2 for Yang et al. Zheng et al. Zheng et al. 4 for Zheng et al. You guys like that one? I thought Albright et al. was a popular one. No? No one likes? Okay, well, hopefully no duplication between you four, okay? Okay, let's see. Yeah, only one for Maina, two for Jan, four for John. Okay, please send me before Thursday, okay? And I'll send an announcement to remind you via Cool. And please fill out the feedback form, okay? I know Daniel and Samuel already heard that in a different class. Okay, any questions for today? We'll finish a bit early. Sorry about that. Any questions about discussion points? Please, if you have something to share related to discussion or a question, please do. Nobody?
Okay, I have a question for the discussion on Thursday. So what we have to list out is like what we like in the structure of the discussion.
Not necessarily what you like, just to
Do something, do an analysis like the color.
here, just choose, you read through the results of discussion. So we've already discussed for all those, I think, the intro,
Yeah.
and even the results we already did a little bit for some. And if you can just read through the discussion aspects and identify some of these points. Okay? You can identify more than two if you want. You know, for instance, if you take everything from one paragraph, you might as well just give me the whole paragraph and highlight each point one by one. Yeah, just give me the slide with those highlights with the label, similar to how I labeled these.
Okay.
Good?
Yeah.
Okay. Yeah?
May I change the paper after reading the discussion?
Sure. Which one?
I'm not sure. I mean, after reading four of the discussion, can I change it?
Oh, you mean if you read the Zhong et al. Discussion and you think, oh, I don't like this one?
Yeah, okay.
Sure, no problem.
Okay.
If you could choose either Maina et al. Or Albrecht et al. If you change. Because we already have two people doing Young et al.
Okay.
Thanks. Maybe change. You're funny, John. Come on. You're a graduate student. You can do whatever you want. Okay, any other question? Okay. So, what's for lunch?